Hello, everyone. Thank you for joining us for today's Caringo Tech Tuesday webinar. The session's topic is Performance Testing Object Storage. I'm Ryan Meek, Principal Solutions Architect at Caringo. And today our guest is Jose Marcos. Jose and I will be available to answer your questions throughout the webinar and at the end of today's presentation. And I will say, stay with us. We have tips and tricks, including client performance tweaks at the end. In addition, we have resources available for you via the attachments and links window on your view screen. If you have any questions after the webinar, you can always reach us by email at info@caringo.com. So I'm Ryan Meek. I've been with Caringo really almost since the beginning. I started as a developer. I've done technical sales. I've done trainings. I've done technical writing. I've done quite a few roles at the company. Jose, why don't you introduce yourself to the crowd too?
Sure thing. Hello everyone. My name is Jose. I've been with Caringo since 2015. I'm originally from Spain, but I live in Canada now. I work with our customers here in Canada as well as in Latin America and the US. My role in Caringo is to provide assistance during product evaluations, as well as architect the final storage platform. I also work with our different partners to integrate their solutions with Caringo's form. Like Ryan said, I'm always available to answer any technical questions, so please feel free to reach out anytime.
Thanks for that, Jose. So moving on a little bit more about Caringo. So we were founded in 2005 to change the economics of storage, designing software from the ground up to solve issues associated with relentless data growth. The flagship product, Swarm, decouples data from applications and hardware and is a foundation for continued data access and analysis with software that stays the same, but hardware that keeps changing and guaranteeing data integrity. So now our solutions are actually used all over the world, I think every continent except Antarctica, and in such places as British Telecom, NEP, Department of Energy, Argonne National Labs, Texas Tech University, the Brazilian court system, the U.S. Department of Defense, and many, many more. So in today's webinar, we will review a very specific case where we did performance testing for a very large supercomputing cluster, scientific data. We'll also review how system architecture affects performance dimensions, best practices, and compliance archive use cases with hundreds of millions of documents. We'll also stick around for questions and answers and a wrap-up. Like I said, stick around. We'll have tips and tricks at the end. So Jose, why don't you take us into STFC and JASMIN?
Yeah, sure. Happy to do. So yeah, let's talk about this use case, the STFC use case. The JASMIN facility is a super data cluster that delivers infrastructure for data analysis like monitoring volcanoes, earthquakes, or even wildlife. As you can see, the goal is clear. Basically, what they want to do is to store absolutely everything, to store it all. So, and we are talking about 10 terabytes of data per day, and with JASMIN working with data sets of over 150 terabytes. This cluster provides both computing and the storage to support more than 3,000 users in 50 universities around the globe. So through capacity needs and the growth rate and demanded a shift from the traditional POSIX file system they were using to a true object storage solutions where RESTful interfaces can be leveraged. That was the whole point of providing a new cluster, a new object storage cluster for this JASMIN super data cluster. So as you can imagine, dealing with large data sets in a high-performance computing environment like this requires that certain throughput requirements must be met. So throughput is kind of key in this scenario, in this high-performance computing scenario. So let's go through the testing environment we put in place for STFC. As you can see in the slide, we tested the system based on the specific requirements STFC has, especially when it comes to file sizes. So it was 2 gigabytes objects for the S3 API testing and 10 gigabytes for the NFS. Networking is key again. That's why STFC provisioned 100 gigabit switches in regards to the Caringo from cluster. We also put in place 12 high-density servers with dual 25 gigabit network interfaces. The protection scheme we used in the cluster was a 5.2 erasure coding. The object storage solution was tested using 20 clients with the hardware that you have described on this slide with 128 gigabytes of RAM on each of the clients, and again, dual 25 gigabit ports.
So Jose, quick question here. So
yeah.
Can you say a little bit more about the client configuration and both maybe the client's configurations that you used and also sort of the standard client configurations that are used in the field at this point?
Yeah, sure. So besides the hardware configuration on the client, which is actually that is something that is that you have to think a little bit about it, right? So first of all, on the hardware side, you want to cache or to have all the data sets that you are going to use to test the cluster, to test the performance of the cluster in RAM. So that's why we have 128 gigabytes of RAM on each of the clients, right? Now, regarding on how to configure the testing tool or what is the best way to run the tests from the client perspective, our advice is to split up the various phases into separate workloads. So you will have like a preparation steps, then you will have writes, and then you will have reads, right? So you can test both reads and writes in the cluster. Also, before doing the large multi-threaded type of test, we recommend that just doing like a small test with a single preparation, write and read workload configuration, just to verify that everything is in place before launching the big test, right? So the preparation step is essentially just about creating all the dummy files that we are going to use and place them in RAM, as we studied before. Then we just write all that information into the cluster, and then we read it back and just get the performance numbers that we get there. Also, it's important that we are talking about throughput in this use case just because of the type of the files and the type of the workloads these guys have with those 2 gigabytes file sizes, right? But there are other metrics that are quite important and that be more relevant to you than just throughput, right? So in that sense, we see objects per second being another important metric to take into consideration. This objects per second or operations per second is quite important, especially if you are dealing with tiny or small files, right? As opposed to deal with 2 gigabytes or multiple megabyte file sizes in the cluster. So I believe objects per second and throughput and latency, of course, those are the three kind of pillars when you want to test a cluster, object-based cluster.
Okay, interesting. We had a question come in asking what kind of tools you used for load generation. I have a feeling that's a good segue into our next slide.
That's right. That's absolutely right. So there is a number of them, and we will talk a little bit about several of them, or at least mention them. In this case, STFC used Bench. What's great about Bench is that it's a distributing load framework, so it can basically orchestrate a testing environment where we have multiple clients that will be pushing and pulling data from and to the object storage cluster. Also, you can define a very specific workload you want to test, and obviously it uses the S3 API. So with Bench, you have a number of benefits, especially because it's, like I said, it's a distributed testing platform that you can use to test your object storage cluster. But yeah, there is a but there. Unfortunately, it comes with limitations. First of all, it has some problems with error handling, meaning that you can find that just stop because of a single error. And also, when it comes to reporting, because it includes both the ramp up and the ramp down, so you have to do some math to get the sustained throughput once you have all the clients actively doing operations on the storage cluster, right? So I think these two are the main limitations that it has. Also, it misses some of the S3 API features like multi-part uploads or parallel range reads, which are useful for downloads. It does something similar to multi-part upload, but it's not a true multi-part upload what it does. But I don't think that there is the perfect test tool. Bench is a good one, especially with when you have multiple clients and you want to orchestrate the test using multiple clients or testing against one single cluster.
So that's interesting. So the numbers, even though they're great, they're not necessarily taking advantage of multi-part writes or multi-part reads, which Swarm definitely can do, right?
Yeah, exactly, and that's basically a limitation on the test tool that STFC decided to use.
So just from our recent experience too, I would say, would you like to comment on sort of the pros and cons of using an industry standard tool versus sort of writing your own?
Yeah, sure. The point using a standard tool is, you have feedback from all over the world. There's a lot of people that have used Bench in the past, or, even ArcClone, AWS CLI, and many other tools that you can use to test your own cluster. So you have that kind of, input or feedback already present, so you know that there are limitations. The good thing about providing your own tool is that, you can basically tailor the tool to test your specific workload that you have in your own environment. The counterpart there, or the kind of the weak point on writing your own tool, well, first of all, is that you have to have a developer that is able to create that tool, and that there is no errors that can lead to misinterpret some of the results that you are getting. So yeah, it's kind of do it on your own. So obviously it has pros and cons.
Okay, thanks. No, that makes sense.
Yeah. So moving on to the results that we got. The requirements were quite specific in this use case. There was about 21.5 gigabytes per second reads and 6.5 gigabytes per second in writes, and that's gigabytes, okay, not gigabits, gigabytes. So Caringo Swarm provided 35 gigabytes per second on reads and 12.5 gigabytes per second on writes. As you can see, we were way above the goal. And on the graphic that you have on this screen right now is essentially how the throughput increases as we add more threads and more clients to the test. So that's the peak was 35 gigabytes per second and 12.5 gigabytes per second. but it was a sustained rate. So when we have all the clients pushing or pulling data from the cluster, that's where we got those numbers. So those exclude essentially the ramp up and the ramp down when you're adding those clients as you move forward.
I think that's interesting about when you. It's interesting. Yeah. Excuse me. When you mentioned that's a sustained number. Could you say a little bit about the way some vendors now seem to be inflating their rates by only including kind of the numbers to cache, and sort of explain how that's different than a sustained rate?
Yeah, sure. So all of this will be coming on later on the tips and tricks, but it's good that we can advance these topics because I think they are quite important. Obviously, if you have a cache in your object storage system and you don't overflow it, all the reads and writes that you are getting, all those numbers, would be great, especially if there is a cache, with SSDs or some kind of high throughput, high performance type of drives, or even NVMe in front of the spindles, of the spindle drives, of the high capacity drives. So I think it's quite important not only to get the sustained throughput, but also to overflow that cache. So you are not seeing kind of the base scenario where when you are basically using the cache, or the system is using the cache to serve those requests. It's also quite important that to test not only when the cluster is empty, but also when you are filling up the cluster with millions of files already in it, right? So I think that the performance numbers will vary a lot, and we have seen this in the field, especially with recently with a customer that wants to test that specific use case. When you have, starting with an empty cluster and then go and write 10 million files, something like that, and test again to see how the performance is different. So sustained throughput is key, not only considering ramp up and ramp down during the actual test, but also these other, edge use cases where it's not, you don't have kind of, a cache that is tampering with your results.
Right.
There is a question, I think, from the audience, right? It's talking about CostBench. We know that CostBench is an old tool that has not been maintained for a while. And STFC just decided to use that tool when they ran the test. This was that's something that they did to test the performance. It's not something that we did intercluster. So we just provide guidance on how to configure things, but the test was responsibility of STFC, and they choose to use CostBench to run that test. Yeah, there are many tools out there, like I mentioned before, from something that as simple as AWS CLI or Alcron that you can wrap up in a script if you wish, right, to do something, a little bit more complex if you wish, or a specific workload with reads and writes simultaneously. You can do a bunch of things with simple tools and run that on a script. S5 CMD is another tool that is quite good. It's another simple tool as well. And also you have, another way of testing is to get a specific appliance or a specific commercial tool to run those tests. So we will talk about a little bit more about that on the next slides. Okay, so moving on to the NFS portion, we just discussed that Caringo Swarm can provide a single namespace between NFS and S3 HTTP. So it means that you can essentially export a packet that is on your object storage system using Swarm NFS. That's the purpose of Swarm NFS. So what we have on this test environment was a single instance of Swarm NFS with up to 16 clients using 10 gigabyte files. And the way that we tested is that we essentially restarted Swarm NFS and cleaned the cache on the kernel every time that we run a different test, right? So that was kind of the methodology that we used to test with the NFS. And these were the results. The requirements were essentially to do 150 megabytes per second on reads and 110 megabytes per second on writes with a single client against a single instance of Swarm NFS. What we got in our test was 349 megabytes per second on reads and 392 megabytes per second on writes, which was way above the goal that was, marked.
So just to emphasize there, that is with a single instance, but there's no limit to the number of instances you can put in front of a Swarm cluster, right?
Yeah, that's right. So Swarm NFS is a stateless system, a stateless solution that basically you can deploy, as many Swarm NFS instances as you wish in your environment, and use this kind of scale-out model to serve more clients and to get more throughput out of the cluster. And because it's a stateless, it means that if Swarm NFS for any reason goes down, there is no caching in between, so you are not losing data in transit or anything like that, right? So I think that's also important, not only the ability to scale out, but also to be resilient if there is any kind of failure.
Makes sense.
Okay, now that you have the real-world example, let's move on to what are the steps to come up with a strategy to run our own performance testing in object storage. I think the first thing that you have to think of is bottlenecks. We have seen this in the field a number of times already. You have to just make sure that you don't have any kind of bottlenecks in the networking. For instance, that you have bottlenecks to do the job. We have sometimes customers that want to test performance, and they go with a couple of 1 gigabit ports on the servers, right? So they're obviously a bottleneck just, right at the very beginning of the test. Also switches and switch configuration. Make sure that, that there is no bottleneck on the switches as well, that you are not connecting 10 gigabit links to a 1 gigabit edge switch at some point or something like that. Again, something that we saw in the field. This example with media and entertainment company, we had some cluster running with 10 gigabit, multiple 10 gigabit links, and they were getting 1 gigabit throughput from a couple of 3 or 4 clients that they have in the office. Well, it turns out that they had a edge switch in that office that was only a 1 gigabit switch. So that's why they were only able to get 1 gigabit throughput back at that time, right? So this is just an example, but there is many of them that can happen. Also, regarding networking is the bonding algorithm. Swarm supports a number of bonding algorithms to aggregate not only to provide the resiliency if a link goes down or if a switch goes down, but also to aggregate the throughput of multiple links. So you can use LACP, for instance. You can use balance ALB. Balance ALB, there is a number of algorithms that Swarm supports. So make sure that your networking infrastructure, is able to handle this kind of bonding algorithms, especially when it comes to LACP, for instance. LACP requires a specific switch configuration. If you don't configure LACP on the switches, Swarm will not work with your connections there, right? So I think it's very, very important to do that. Also, before doing any kind of test with the object storage platform itself, just use a simple tool like iPerf to verify that the throughput that you have on your lines, on the network communications. So just make sure that if you have a 10 gigabit link between the clients and the cluster, you can maximize that throughput. Like I said, using iPerf, for instance, will be the best. It's a simple test to run before actually starting any kind of deep testing on the object storage platform. Another bottleneck that may happen is the HBA. The HBA is basically the disk controller that you have on your system. It's important, especially if you're dealing with high density chassis. So let's say that you have 60 drives on a single server chassis. And for some mistake or for some reason, someone decided to put like an 8-lane SAS, say 6 gigabit type of card in there. So you will be hitting a limitation on the amount of on the throughput that that HVA that this controller is able to handle, right? So again, another thing that is easy to avoid, but just double check that there is no limitations there. Also, jump to the BIOS. Take a look at the BIOS. If there is kind of a specific configuration regarding energy saving or green mode or anything like that, we are very conscious on the planet, but if you want the best performance, it's best the BIOS is set up for maximum performance type of load.
So just so we're clear, Jose, are you recommending we do not take care of the planet here?
I do recommend to take care of the planet. It's just allow you to just to verify all these configurations and be green where you can be green, right? If you have to get performance out of a system, don't use this kind of green saving type of feature on the BIOS, because the BIOS will tend to lower the power of consumption on the processor, or even spin down the disk drives, or there's a number of things that the BIOS can do on the low level on the hardware. So just make sure that, at least not for testing the performance, make sure that it's in high performance or maximum performance mode. I think the last one is the object storage architecture itself, right? So you may think that your object storage system is, it's a great system that scales out and that is able to handle, very high throughput connections and so on. But you may not know that there are some limitations in the architecture itself. For instance, some of the object storage solutions in the market use a file system in the backend. So you think that you are writing to an object storage platform, but in the end it's using ext4 or JFS or any kind of Linux file system to format the disk drives and to store your data there. So that's okay if you don't want to store a lot of files, millions of files there, or I guess that's okay in that scenario. But the moment that you start to grow and you start to store multiple files, or even large files, or even the tiny files, right? You will hit a limitation on the file system. I can give you an example there. This is another real use case scenario. We have a customer that is storing right now 150 terabytes of is used in their cluster, but they are storing like 10 billion files right now. So if you have a file system that has to store 10 billion files, it will have a hard time to do that, right? So make sure that you don't hit this kind of limitations on the backend, on the actual architecture of the object storage solution that you put in place. Ring architectures, that's something that also affects performance. There are kind of two approaches when it comes to architect the object storage solution. One is using a mesh architecture like Swarm. So basically in Swarm, all the nodes perform more functions, and when you are adding a new node to the cluster, you are increasing not only the space available in the cluster, but also the performance that you can get, because you get, you have more CPU cores, you have more, ports, network ports there, and you have more spindles to take care of requests. So that's the mesh approach. The other approach is ring. The ring architecture basically defines a ring, which is a set of servers that will take care of a specific data protection scheme. So let's say that you want to do 4-2 erasure coding, 4 data segments, 2 parity segments. So you have to provision like a ring with 6 servers, right? And then you want to do full replicas, so like a RAID 1, but based on per file basis or per object basis. So you decide to provision 3 servers on a different ring. So you are essentially creating subgroups of hardware. So when you are writing to a large file in this kind of system, you are using 6 servers to write that file. When you write a small file, you are using just 3 servers to write that file. So the performance will vary a lot, and you are not getting the performance that you can get if you put all together, like in a mesh architecture, right? So in that example will be 9 servers if you use something like Swarm, right? So Swarm can take care of protecting your data with replicas and erasure coding in the same level of hardware. So you don't have to assign a specific hardware to take care of the specific protection schemes, right? So I think that's quite relevant as well. We discussed this again, these proxies and cache and dependency. When you test your environment, there are some solutions that put in place like a couple of SSD drives in front of the spinning drives. So if you are testing that kind of object storage solution, probably it will be very fast until you overflow that cache, right? So that will lead to unexpected results. And this is critical, especially if you're in production, right? And if you don't do like a very thoughtful test on this kind of systems, making sure that, like I said, you overflow the cache and you are just testing against the spinning drives that you have below the scenes, for the capacity drives, you will think that your system is able to do, a number of megabytes per second that is not actually real, right? When you put that system into production and you have, multiple clients accessing different information, and that's not on the cache on the system, right? So again, something to take into consideration. Okay, moving on to tools, and we have kind of covered a little bit of this. The first thing that you see on this slide is about synthetic data versus real data. So what's synthetic data? Well, essentially it's random files that you create to test your object storage solution, right? So those 2 GB files that we mentioned in the STFC use case were basically, garbage type of files that the purpose was to have this kind of 2 GB files because it's the average file size that STFC uses. So that's why we went with 2 GB files. Real data means that you are using, what your product, what your application produces. Let's say that you have an application or a system that produces a number of files with very different file sizes. So I think in that use cases, it's better if you can test with real data instead of random files that you create. Now, regarding the actual tools that we use to test, you have, like I said, simple tools like rclone, AWS CLI, S5 CMD. Even Wasabi has its own performance testing tool that you can use to test your own S3 compatible object storage cluster, right? But also there are paid tools, like for instance the Virtona Workload Wisdom, which is an appliance. We use this, a customer used this appliance recently to test Swarm. It was that use case that where they were filling up the cluster and see how it behaves as you fill up the cluster. And well, we discussed this again on a question before, but there is kind of 2 different tools to test. One are the publicly available, that the one that I mentioned, versus homegrown tools. So basically, versus things that you can create by yourself or you can develop by yourself to test your specific workload. Finally, some tips. Let's do some tips. So I think it's more they're kind of obviously, let's say, but it's important to keep that in mind. Just try to verify that the tool measurements that is providing you or the result that the tool is providing you are actually real. How can you do that? Just take a look at the logs on the object storage system. At least Swarm, I don't know others, but at least Swarm, you can get very specific information about the operations that are happening in the cluster. So it means that, you can compare what the object storage is telling you about the latency or the time that it took to complete the operation versus what the test tool is, is providing you as the result, right? At the aggregate throughput or something like that. So just make sure that both things match. Then provide useful metrics. Yeah, sorry.
Excuse me. Yeah. So does that mean you probably don't even need a distributed test tool, but you could actually calculate the throughput of the cluster using the logging analytics?
Yeah, you can leverage, in the case of Swarm, you have logging analytics built into the product that you can leverage to know what's going on in the cluster and use that to compare to what the tool is telling you that are the results. Yeah, for sure.
That might be useful where people, they don't have a complicated or expensive distributed system, but they can, they can write files in a loop from as many clients as they have, and then they can see the overall cluster throughput based on the logging.
Yeah, that's right. In that sense, useful metrics is something that, is relevant for just to think about what is useful for you. Like I said, if you are dealing with tiny files, the throughput, I don't think that is a useful metric for you, right? It's way more important that you get the operations per second or objects per second that the system is able to, to process, rather than, kilobytes per second or megabytes per second throughput with tiny or small files, right? On the opposite side, if you are dealing with multiple megabyte, gigabyte type of file sizes, I think throughput will be key in that type of a scenario. Also, only take into consideration repeatable results. It means that, if I hit enter on a test and I get 100 gigabytes per second or something like that just once, and then I just got 60 gigabytes per second in the next test, and I repeat the test and I get 60 again, 60, 60, 60, obviously I think that you may want to consider 60 gigabytes per second and not 100 gigabytes per second as the actual result of the test, right? As I mentioned, overflow the cache that the system may have, right? So do as many operations required with as many clients as you can get to reach that limit. So usually, start slow. So let's start with one client with 5 threads, ramp up to 10 threads, ramp up to 20 threads, then put another client, and repeat the process to see where are the limits of the object storage. If it's the client that is not able to push more data, or if it's the object storage platform which is not able to provide, better throughput on what you are doing on that scenario. And the last one is the one that I mentioned already in advance before, is fill up the cluster. And I think that's also important. Not only to test when the cluster is empty, because you will get different numbers, very likely, especially if the object storage solution uses a file system behind the scenes. That will be key for you to test, right? So that's why we just recommend to fill up the cluster, store millions of files, even if they are dummy files, doesn't matter, and then repeat the test again, just to make sure that that you will get the same performance from the day one that you start the service than 5 years from now when you are in maybe 70% of level of occupancy or something like that, right? So that the performance does not degrade as you are increasing the object count or the capacity used in the cluster. So I think that's another key point that you want to test in your environment.
That's a good point too. I mean, if you can't fill the cluster fast enough to get meaningful data points, that might be part of your answer. Like there's not enough throughput available.
That's right. Yeah, I think that's pretty much, that covers our presentation today.
Well, thank you very much.
Yeah,
thank you very much, Jose. If there are any questions left, we can certainly stick around and try to answer them for you. But I think we got to the ones that came in. Thanks everyone for joining us today. To keep up with us at Caringo, follow us on Twitter, LinkedIn, or Facebook. If there's additional questions or you'd like us to schedule a demo or talk to you more about performance testing, please email us at info@caringo.com. I'd also like to invite you to join us in October for our next Tech Tuesday webinar, Developing Cloud Native Applications. Thanks everyone, and we'll see you next month.
Thank you all.